Good evening. It's 8:30 in Istanbul and 7:30 in Berlin. We are live on Zoom and we are live on YouTube right now at the online interviews organized by INda. Sorry. I'd like to welcome all the students, all our fellow partners, all the professionals from the industry, and those who are related or not, interested in sustainable materials and smart materials tonight. And also, I'd like to give a brief explanation about INda. I'd like to make a brief explanation about what INda is for those who have not attended in our previous meetings. INda is a peer-reviewed magazine in the field of interior design and interior design education. It also aims to make versatile contributions to the field in the sense of sharing scientific knowledge. And to this goal, tonight we have a very special guest from Germany. I'm sorry, I just have to write. Okay, I'm just dealing with live streams. Okay, tonight we have a very special guest from Germany. He is, let me mute my phone, okay. He is the founder of Future Agency for Material and Technology. He is one of the most known materials and technology experts in Europe. He is a scientist, an innovation consultant, and a design engineer. He is also a member of many contests, design contests and competitions in Europe and worldwide. But the most known one in Turkey is the Red Dot Design Award. He is a consistent jury member of Red Dot Design Award. And he has given more than 200 lectures worldwide, of course face-to-face, not online. He has given 2 lectures in Turkey, as far as I know, and this will be the 3rd one in Turkey. Willkommen, Herr Peters. Can you hear me?
Yeah, I can hear you. Thanks. Thanks a lot for the invitation.
Thanks, and actually, I don't know if I pronounce it, it's alright, but es freut mich, dass Sie heute Abend beim Online-Interview hier sind.
Super.
Thank you, but this magazine is bilingual, and those 2 languages are Turkish and English, so I am only allowed to speak English or Turkish. Which one would you prefer?
English.
Okay, then. Okay, so Prof. Peters, I tried to make an introduction, but please tell us about yourself and your identity as a researcher in materials, please.
Yeah, I started writing books about materials. It was about 18 years ago. So I follow the research and the developments in materials since then. So yeah, we see the different developments in the focus on materials. You noticed a materials box which I gave you.
Yeah, I remember.
Five years ago.
Yeah, exactly.
It's a box which we did for the European Communion to show the potential of smart materials. That was 10 years ago, so 2010. They asked us to develop a new box.
Really?
And this is the result. A new box. It's the Green Innovation Materials box. And this is about materials for the European Green Deal. So it's about sustainability. One example or one material which we show in the box is a leather alternative made more or less completely out of apple trester, which is the material, the cellulose fibers, which you get from residues from the apple juice production. So that's quite amazing material to see, produced in Italy, by the way, in the north of Italy. So we are now turning from high advanced smart materials into the field of sustainability.
Mm-hmm. And your identity as a researcher, how can you identify yourself? Where does this interest come from, and why are you doing this kind of weird stuff?
Yeah, I worked at Fraunhofer for 5 years, end of the 90s, and then I realized maybe I have to do something in between product design and mechanical engineering. Mm-hmm. So I found crazy stuff in the part of materials which were developed by engineers but used by designers, and they had a gap in between talking to each other. So I was the translator in between these two worlds, talking about materials. That's how I come to materials. And now I'm specialized somewhere in between, and do a translation in the sense that it's high tech in a way, but you have to use it in an application, and this is what designers do and architects do. So that's what we are working with.
Exactly. And Prof. Peters, this interview concentrates on the introduction to different types of smart materials, of course, and their potential application in various areas, but of course mostly in interior design. As far as I'm concerned, thousands of years ago and still today, humans use materials to to identify their age and use materials for different causes, due to which there was an enhancement in their living standards. Even civilizations were classified for materials like Stone Age, Bronze Age, and Iron Age. And today I can call as a synthetic age, if I may. And we are living in a synthetic age, that's what I think. And when we talk about today, as far as I know, some couple of decades, I can say 20 or 30 years, I can say, science and technology have made great improvements in synthesizing new materials. And today, there are various categories of materials. Among them, smart materials and nowadays sustainable materials are becoming more popular because they have various applications as compared to standard materials. For example, in that box you gave me, I remember that there were 5 materials, and by now, as soon as I come to Berlin, I want one green box as well.
You get one.
Or when you come to Istanbul, either way, or Antalya maybe, who knows. So smart materials, I think they play a pivotal role in changing the way industries operate. And these materials help designing the future and futuristic products for a wide range of industries, such as aerospace, such as automotive infrastructure, and design of our daily gadgets in also our daily spaces. So, Prof. Peters, could you share some up-to-date smart materials and sustainable materials that are or may be revolutionary in interior space?
Of course. I have made a little presentation, and I would like to show you.
We would love to see.
So, but first of all, I would like to start with this image. That's in German, but I think you have
Fridays for Future. Yeah, we all know about
things going on in Turkey as well.
Yep.
We all
Greta
know.
Thunberg.
Yeah, of course. I mean, she's right in what she's saying. So we all know that we have to do something against global warming. And if the pandemic situation would not have taken our whole interest in the last 2 years, then probably sustainability would be the most important issue, and it would be the most important issue for the next decade.
I couldn't agree more.
Yeah. So we are overstepping ourselves, and we did this for the last 50 years. We use more resources than the planet can give us, and we produce more emissions than nature is able to absorb. So in 2020, we took 160% of the global biocapacity out, and this is not possible anymore in future. When we do it like we did in the past, we live and we work like we did in the past, then in 2050 we need 3 planets, and this is not possible to do. So we now have to find a way, with all the innovations we did in the last decades, to transform them and our way of living into a way that we use just the planet we have. Probably in 2030 or 40, we have to do it in this way. And yeah, this is the future circular economy. A solution and a concept where resources circle in endless circles. We have the technological circle, we have the biological circle. Reuse, refurbish, recycle are the aspects for the technological one. And we as a future agency now see the most far-reaching innovations and the most far-reaching potentials for innovation in the biological circle. And it's very, very interesting to see this process now, because a lot of traditional materials and materials which are not obvious to use in the industry are coming up right now. For example, Adita a designer from Tel Aviv, she came up with the idea of just using clay and natural fibers to transform them into the modern world and use them for furniture design, for interior design. In Eindhoven, when she studied a couple of years ago, and yeah, that was her work. I think it was 2014, and she's now starting her business with the idea of a circular earth technology, where recycling and reusing of the material is the key point of the whole business case. And she found a way to create materials like that, these tiles, 100% biological, biodegradable, by the way, and 100% transforming into modern interior design, like what you
Are
can
they
see
durable?
there.
Are they durable for the chemical effects, like cleaning or whatever, for the friction?
Yeah. I mean, that's I wouldn't say that it's 100%, but it's in that it's all developing in the right direction.
Looks fantastic.
Another example which I want to show to you is that this is a designer from London, a French designer, Eric de Laurence. 2012, I think, was his master thesis. He studied at Royal College of Art, and he did a project by using these little tiny, what would you say, residues of the fish industry, called fish scales. And he found out that there is a thermoplastic adhesive in the the scales. So he just need to press the scales and put some energy, some temperature in it to produce cups from it. We had these cups in an exhibition in 2013, and now he started his own business. I just found it by chance 2 weeks ago, and I wrote him an email. He founded a company called Scalite in France. I hope that it's the right spelling. And this is his material, 100% made from fish scales, super hard and stiff. And I guess he would like to use it in interior design, but I could also imagine to use it in other application fields. Then we are more and more into that 100% possible ways of 100% circle in the biological field, in the biological circle. And we found this, the so-called sunflower board from a Dutch designer called Thomas Whaley. He did this development in Arles. I think it was at the Luma lab. He found residues, agricultural residues like sunflower fibers. When you get the sunflower cores from the plant to make oil out of it, then you have a oil rest of oil in the cores. You bring all together, like the fibers and the cores. You polymerize the oil, and then you use the polymerized oil as a binding agent. So he was able to produce a board 100% biodegradable, 100% bio-based, which is used, for example, in furniture design. Very, very interesting material development. Another one from Zurich, the company is called Question. The material is called Banana Tex. They use banana fiber. They had the task of creating a textile, 100% natural, 100% biodegradable, to use it as a material for bag production. So they found a way to transform the plants of a banana tree, so the residues when you get off the bananas, transformed into paper first, and then you make a fiber out of the paper, and you produce a textile from the fiber, the paper fibers, which are made from banana fibers. And then finally, they were able to produce a material which is really, really strong and stiff. They call it the first natural technical textile. And they use it to produce bags. For example, they can also imagine to use it in automotive, for seats, whatever you can imagine, furniture design, but why not having these textiles also in the interior design? So Banana Tex, one material we found for the biological circle. Another material innovation comes from, where is the, I showed you the apple leather. A lot of developments taking place right now to get alternatives to animal-based leather. So one comes from Mexico, from Guadalajara. They use the cactus leaf to produce cellulose powder from the leaves, and then bring this cellulose polymerize the cellulose and bring this onto a textile and make a leather out of it. So that's the material. They sent this to us to show it around.
That's great.
Directly from Mexico.
It
So
doesn't look artificial.
These are the two guys. They say, I mean, you have to take care, because they say it's 100% bio-based, but it's partially biodegradable. So obviously they're mixing something into which they didn't mention. You have to read.
But still, instead of killing animals.
Of course. It's a way, it's a step into the right direction.
Exactly.
Another one, so we found things in France, in Italy, in England, Switzerland, Israel, Mexico. That's from Spain, from Barcelona. A company called Honex. It's a spin-off of the university. They found a way to transform cellulose fibers from recycled paper, from recycled cardboards into boards for interior design. 100% based on these cellulose fibers, 100% biodegradable, zero waste production, because they found a way to use enzymes in a treatment for the cellulose fibers to produce binding agents in between the fibers. I don't know exactly how it works, but finally they have found a way to produce that boards without any chemical substance inside, without any petrochemical plastic or resin inside.
That's a revolutionary. Yeah, that's revolutionary.
100% biodegradable. Wow. That's one of the future. Yeah. And you see, I mean, it works in the interior design.
Is this that material that made of that boards, that paper boards?
Yeah.
Oh my gosh.
Another material based on cellulose fibers comes from Sweden. The company is called Bo, one of the main producers of acoustic boards, acoustic solutions. They came up with the idea of a world's first biodegradable sound absorbing material. You see the ingredients. I don't know exactly how much of
citrus
they put
lemon?
in. Yeah, lemon, lime, water, pine wax. So everything mixed together, and finally they have that board. So the white one in the center of the image is the solution, and it's biodegradable. Wow! I mean, normally you have all that shit from the petrol industry in a board like this, and in that case you don't have anything. So, and it's fire resistant, water repellent, and strong enough to work as a panel solution.
So fire resistant from pine cones?
No, I don't think that pine cone. I don't know
it's
where
explosive,
the fire resistance is coming from, but
okay, exactly, perfect.
We found another example. That's maybe not interior design, but I can imagine that it could be used there. It was firstly presented at our conference, Green Smart Materials, we did for the Interzoom fair in Cologne. It was a digital one, of course, in May this year. The company is called Swiss Wood Solutions, and they found a way to densify wood in a way that they can produce a thin, tiny veneer out of it, which has a light translucent qualities.
Serious?
No plastic inside. No plastic inside. And it is possible to use that material as a surface on top of a wooden board to integrate touch sensitive qualities, because they can print electric circuits on it.
That's like science fiction.
It's not. It's there. Yeah, we are preparing an exhibition, so it's one of them. I have some boxes around there, so we have that material in the exhibition. But it's just
incredible. Like on wood, and you enlight it and you write, and it's like lighted, like
wood
stripes.
and metal circuits printed on it.
Of course, but still.
Biodegradable, no plastics inside. Another one from Finland this time. Probably you know that the color of a butterfly is not a pigment.
Yeah.
It's just a structure of
exactly.
the surface where light is reflected in a way that you see black or blue or green or whatever.
Yes.
It's not a pigment, it's not a color, it's not lacquer or something, it's just a structure. As you can see it here.
Mm-hmm.
Researchers from Aalto University and designers found a way to bring this structure onto wooden board and have the possibility of this color emitting translucent reflection without having a lacquer.
Yeah,
I have that.
it's like lacquered, but it's
wood.
not.
It's not a lacquer. It looks a little
It's
bit
just
like
a surface, right?
It's just the surface. It's 100% cellulose.
Mm-hmm.
They bring the structure on nano dimension into the board. Wow. And see what structures they are able to produce. Biodegradable, by the way, and never fade away.
Never.
The only way to get it off is just to scratch it.
Yeah, or friction.
It works like this. That's not so. It's not so strong. In a way, I have light here.
No, we can see. It's,
so like a mirror.
you can perceive.
And even in the night, it looks quite amazing. It's called Shimmering Wood, the project.
Mm-hmm.
And it even works on burnt wood. So they burnt the wood and it's black, and then they bring the surface onto the wood and it has a color again. The black wood has a color. So that's in a way smart, okay? Yes. Then another field, so we focus on smart materials, on lightweight, on sustainability, and we also focus on additive manufacturing, 3D printing, and we see a lot of developments in filament or granular printing, where they want to use wooden fibers as the resource and try to create wood in a way. That's what BLB is doing. BLB is a company from Sweden, Värnamo near Jönköping. That's in between Göteborg and Stockholm in Småland, where the inventors come from, the Swedish one. They have a big printer. It could be 5 by 5 by 5 meters. That one is 2 meters and 2 meters high. They sold it to Nordan. It's a Norway producer of windows. And this company is starting to produce wooden windows from it. I mean, not
3D printing wooden? Are they
Yeah.
3D printing wooden windows?
Yeah, I show you because I have that window in our office. So that's the window. Look, it's printed. You see the lines, and you can.
So is it artificial or natural? I seriously cannot distinguish. I mean,
Yeah, it looks like wood. Probably it's 60
but it's made of wood.
Yeah, it's probably 60 or 70% wood, and the rest is PLA or lignin. I don't know exactly. So PLA is based on starch, and lignin is based on any kind of plant, also trees. So it's a natural binding system, but it's not biodegradable under normal circumstances. So you have to bring it in an industrial atmosphere, high temperature, high humidity. So special conditions, but it's the right way, because in Germany, researchers found a way to make a wood-based biopaste for 3D printing. That's not a granular. It's like a liquor. 50% lignin, 50% cellulose, and biodegradable. That's research. It's just presented last year in summer. I recently found that. That's really interesting to see.
So they do not shatter any precious plastics?
No. So no petrochemical process. That is really interesting. So 3D printing of a mixture of peels from orange and starch from any kind of plants where you can get starch off. So that's the first lab. Yeah, it was so they made a Kickstarter campaign, and this was just sent last week. Yeah, interesting to see.
Interesting, yeah.
From Sicily.
Yeah.
Because they have a problem in getting rid of the peels of the oranges, because they have so many. They are producing juice from it, so they have a lot of residues which they can use to produce materials from. And then the last one, probably you know that you can produce materials from mushrooms. Mushrooms eat cellulose, like wooden powder. So you spray the mushrooms on top of the wood, and then the mushrooms start to grow. They produce little tiny fibers called mycelium, and it finally, after 3 or 4 days of growing, you got something like this, like a block. You can use it as a building material, depending on which mushroom you use and which food you give to that mushroom. In Singapore, a Spanish researcher called Fernandez used this kind of mushroom called omicete, mixing it with chitin from the cores of lobster, by the way, and cellulose from trees, and mix it to a printing paste, and they were able to print a turbine blade. This was one of the most successful research projects published in 2018. We read this article because they say that this blade is produced with a cost of $8.
Eight.
Eight. Super strong, super hard, and
Super cheap.
100% biodegradable. We had holidays in Southeast Asia, and then we had a stop over in Singapore. I called that guy and said, okay, we would like to present your blade in an exhibition. And then he just gave it to us. So that's the blade. This one in the image. Then Corona came, so we had not the chance to show it. That's why we still have it. So that's the blade, 5 kilograms strong, and it's not metal, but it's super, super, super hard. And they used it to print. This is world's largest ever printed biological structure for the architecture, because it wasn't done before. That's the guy, Javier Fernandez, and this is his 5-meter high column, which he produced for the 10 years anniversary of the Singapore University of Design and Engineering near the Singapore airport and near the fairground. If you have ever time to go there, it's worth to see. Yeah, so that's the last image. We are writing books about these kind of materials. The last one was published in 2019 in German and also in English. So if you would like to have more inspiration, you can see and find them in that books. Yeah, thanks a lot.
No, thank you. And Prof. Peters, as we have seen in your presentation, I have noticed that the use of these materials requires high investments, as I think. And thus, various governmental and non-governmental bodies should focus on increasing awareness and promote usage of these kind of sustainable and smart materials. What are your opinions for a future scenario in using these materials? In the beginning, you already mentioned about the worst scenarios of the Earth, of our planet. I mean, the resources. But I'm talking about in the industry and in our daily lives, in the public. What is your opinion?
So in the last few weeks, we got a lot of emails from companies that are interested in using sustainable materials for their products. And their products are not like small and tiny bags. It's more like planes or trains or cars or something like this. They want to have solutions in a way that their product is more sustainable in future, because they know that it's the only way to do, and they know that the clients ask for these kind of solutions. If they're not transforming into that way, they will disappear within the next, I don't know, 3, 4, 5 years. So they're all into that area. If it's possible for small company or for a big company or for a designer to bring a material development into a successful product, I don't know. I mean, there are hundreds of ways. Some are promoted by government, some are promoted by research institutes, but some just did their way or find their way, like the guy in France did. So it's not easy to answer this question, because you have so many different characters also. Yeah? I mean, we find our way to work with materials. We also develop some, by the way, for companies. It's not easy. I mean, it's not like writing an algorithm and then you have created Facebook, and you expand in a moment. You expand like a billion worth company. It's not like this. You need more machines, and so
But it's more centralized, like the producers, not the public as we, I mean, not we are the designers, but the public. I mean, in the Facebook, when you write the algorithm, it goes directly to the public and it goes like a boom in one night, or let's say 1 week, but not 1 month. But in these kind of smart materials, it's centralized to the manufacturers and the investors. But also, I did come to an idea that the materials that you mentioned in the presentation have lots of benefits, like sustainability, including advances in recycling and reuse, improved energy efficiency, and high-level performances. How about the barriers in using these kind of materials? For example, can high research costs or ongoing production processes in huge industries, like you are you are also the consultants of lots of huge industrial companies, these ongoing production processes are an obstacle in front of these kind of materials, or what other obstacles do you foresee for this kind of materials to get into our daily life?
It's very tough to bring a new material into successful application when there is another material like all this plastic
cheap.
I mean, they are in the world for 5 decades now, more or less.
After the Second World War.
Of course, and the production technology is optimized within that period, and to bring all these new ideas onto that level is in some way it's impossible. So the politics need to bring limits, and laws will change a lot. If CO2 price will rise in future, then a lot of business cases are not possible to do anymore, and then they looking for alternatives. Look what happened to the car industry. Without,
I think Norway did some kind of limitations in the the conventional cars, so they have to, or I think in some states of Germany as well, right? Am I right? Or
no, it's a European law, and it has to do with the CO2 emissions in total does not have to be above a line, and otherwise you have to pay, and the producers wait.
No, I'm talking about completely banning those fuel.
Of course.
Not only the limitation of CO2, it's the same in Turkey, but banning the fuel oil cars, just converting transforming them to electric cars. I mean,
they
may be a humor as well, or a rumor.
And I mean, Norway is doing that because they have 96% renewable energy. That's the reason, of course, and they don't have car producers, so
they don't have energy, so they can ban it. Peters, we have a question from one of our participants, Aleyna Özgen. She has asked about the installation of that window, that the wooden one, the circular wooden one, how to get it fixed. And also,
I don't know.
yeah, also, but maybe they can follow some links and they may see the installation details. And also, our head of the editorial board, Şebnem Ertaş-Beşir, she's an associate prof in Akdeniz University. She has mentioned that it is important that designs are produced with natural fibers and materials, that they have a longer lifespan and that they can be recycled. To what extent does the cost of production affect its spread? Do you want me to repeat the question? To what extent does the cost of production?
I don't understand the question.
You can see it on the chat board if you need to.
Yeah.
If you click on the chat button, just by the share screen, you can see the questions. Since you are the co-host, could you see the question, or do you want me to repeat?
Affect its spread. I don't understand that. No, I mean, you can't discuss the different possibilities of long lifespan and recyclability of a material. It's always different in different applications. So it depends on the single product, on the single application, which way is the best to do. A longer lifespan or a shorter lifespan to bring the resources back and in the circle. That could be also an option, and that's the opposite way of long lifespan. Maybe that's an answer to that question.
Okay then. Okay, Prof. Peters, in the name of the editorial board and myself, I'd like to express our gratitude for your time and generosity in sharing your researches. And I am on my tenterhooks to see the design market, which outlooks for smart materials, smart structures, and their associated applications. And hopefully, appears to be quite promising in the near future. But for sure, I mean, I don't know, maybe us or our children will definitely see those days. Because once my daughter asked my mom what innovations did she have comparing to her mom, and she said that her mom did not have any microwave ovens, did not have stainless steel pots and so on. But one day maybe she would say that my mom used to cook in the oven, but now I'm gonna 3D print my dishes. No, I'm 3D printing my dishes. Who knows what happens in the future? But we as the designers, I think we are responsible in all those questions, in spreading those materials. Of course, we cannot, combat with the costs of production stuff, but still designing and putting into daily life, I think we have the responsibility, not innovating, maybe not invention, but turning it into daily life. I think it's our responsibility as designers and interior designers or product designers.
Of course,
agree?
Of course, I agree.
Okay, then. Do you have anything else to add, or our time is almost ending? It was about 1 hour, and we have 10 more minutes left if you want to, or we can.
No, thanks.
Call it down. Okay, Prof. Peters, thank you very much for your knowledge, and thank you all of our participants, students, and our fellow partners. So next week on Wednesday, we will be together with Prof. Marcus Cruz, and he is going to share his knowledge about bio-integrated design, who also is a friend of Sascha Peters as well. He remembers you from Antalya as well. Probably you remember him as well.
Ah, yeah, okay, the guy from London, right?
Yeah, good guy from London.
Okay.
Peter Cook, he works with, and he is right now the head of Bartlett School.
Yeah.
Okay then. See you next time. Thank you very much. Goodbye.
Thank you. Bye-bye.
Bye.
Bye-bye.